Hello and welcome to the STEMCstudio channel. In this video, we are going to take a look at automated testing in STEMCstudio, why you would do it, and how you would do it. So let's ask the question why you would do something like this. It really kind of comes down to your analysis of the cost for you of the failure of your software. Okay, how does that compare to the upfront costs of investing more time in development and testing to get your software right versus the cost of what happens if it fails? What are going to be the costs to you if you have to fix the software, and how easy is it going to be to fix your software? Now, clearly in STEMCstudio, our software is not going to be running on Mars, or it's not going to be running inside somebody's body. So really it kind of comes down to what does it mean for you in terms of making sure that your software stays running correctly. Now, in STEMCstudio, my philosophy is that the student should really build things from scratch, and rather than reaching for like a physics engine or something like that, because it doesn't teach you anything. And therefore, and because the STEMCstudio allows you to have fairly complex projects, the possibility exists that you may be writing some, quite powerful but complicated mathematical objects that need to be tested. So that's kind of like why in STEMCstudio, it's perhaps not about the usual reasons why software has to be kind of correct. In general, of course, software, we have other issues like the trust of your users, people using your software, other lives at stake. If your software crashes, do people lose their lives? But I think kind of what it comes down to mostly in STEMCstudio, I think this is what makes software testing kind of like more of an interesting, fun challenge, because it can seem like a very dry and boring subject, is it's really about kind of like pride in your craft. Are you going to be able to write a simulation and have a lot of confidence in your simulation that it's absolutely running kind of like perfectly, whatever you try to do with it. Okay, so what sort of kinds of software testing, or what layers of sophistication can you have in software testing? I think that there are really three kinds of layers. The first layer, the minimal level, if you like, is that you should be able to determine whether your software passes a certain number of tests. How many pass, how many fail, what's the total? And that's kind of like the minimum for automated testing. If you're developing a library, you kind of like want to go that other people are going to use. You want to kind of go deeper than that. So you want to kind of like say, okay, can we test how much of our code is actually being tested, right? What's the code coverage is what we call that. And then finally, there's another kind of testing, which is a sort of destructive testing in a sense, but not destructive in the sense that you just destroy the software. But a testing tool changes a little bit of your code, and it determines whether you have a test to actually catch that. And so it really tests whether determines whether your tests are really actually checking your code, or are they just running through it, just executing it, right? Because it's one thing for a calculator to run and spit out a number and not kind of like burst into flames, but it's quite a different thing for it to actually spit out the right number that you need. Okay, so how do you do testing? So we're going to talk about specifically how it happens in STEMCstudio in a minute, but I just want to kind of like talk about some general principles. And the general principles I've kind of outlined down here. Let's hide the code for a minute, hide me rather. So goodbye. And the testing really kind of like happens in three phases. So if we look over here, for example, where I'm trying to test this complex number class, which is in here if you're interested, I'm trying to test this class, and there are three kind of phases. The first phase, which is this sort of block up here, is where I set up the problem. I set up the test that I'm trying to do. The second phase, which doesn't break out quite so clearly, is where we actually execute the code that we're interested in testing. And then the final phase is where we check the results. So you can see here, when we check the results, the way that we do that is we expect, and we call a function called expect, and that takes the actual value that we got, and we expect it to be, and this is kind of like the expected value. Okay, so it always happens in kind of like 3 phases. You set up, you execute the code, and then you assert the outcomes. So that's the general, that's going to be true kind of pretty much whatever testing you're doing. I don't know if I've convinced you yet whether you should be doing testing in STEMCstudio. I hope I have, but I want to tell you as well about a philosophy in professional software development called test-driven development. The idea of test-driven development is that you write a test before you actually write the code that you're trying to execute. And then what you do is you implement the code, and you implement the absolute minimum, simplest solution that you can do. And then you progressively add more tests, constraining the way that your code behaves more and more through the tests. And as each test that you add fails because it's not implemented correctly, you go back and fix the code. So you have this kind of iteration going on where you write a bit of test, you go and fix the code, write test, fix the code. Now, some people get really dogmatic about this, to the extent that, they'll say, oh, write the test before you even have any code, and I think, you can kind of like play with this a little bit and find kind of like what works best for you. But generally, it's a really kind of like good idea to kind of like have kind of in your back pocket this idea of test-driven development. And it has the added benefit of making sure that you kind of like see the code that you're creating from the perspective of somebody who's using it. That person using it effectively are your test cases. So this is what we call eating your own dog food, right? And the idea is that if you can see how you use it, you can say, okay, my APIs make sense, my interfaces make sense, or they just kind of like, they look kind of like strange, and I really need to kind of like, change the philosophy or whatever. So that can be a way to actually improve the quality as well of your code. Okay, so we have talked a little bit about the sort of the whys and the general hows, and also kind of like the sort of the philosophy for it. Let's kind of like get into STEMCstudio specifics. Okay, so I'm going to stay with this project just for a minute, which, as I said, is testing a complex number. This complex number is not, to use a pun here, it's not too complex, not too complicated. But there's stuff that, this bit of code here that's kind of calculating the multiplication. There are pluses and minuses going on here, and you can make mistakes and stuff like that. Does this really kind of like work kind of like correctly? So I think that when you start doing stuff like this and you're creating functions, mathematical functions that are like the bedrock of your simulation, that it's really a good idea to actually kind of like write some pretty comprehensive tests for them. Okay. So in this case, what we do is we have the complex file. This is your code, right? And we separate it from the test cases by putting the test cases in a separate file, which by convention, in STEMCstudio at least, we call complex.spec.ts here. It's got the same root as the other file that we're trying to test, but we've put a little spec with periods around it just between the two. In desktop type development, real professional development, this can actually have a real purpose from the point of view that it's a way of the system scanning and finding your test files. In STEMCstudio, this is really just a kind of convention just to help you kind of like keep the things together. So it's not super important. Okay, so let's just talk about the whole structure of how this thing, how these tests actually get run. So in STEMCstudio, one of the big ideas, there aren't many ideas to actually remember, but one of the big ideas to remember is that a project can have multiple programs that can run. And this is why we're able to create a test program in the same project as your normal program. So a program is going to be associated with an HTML file. Okay, so you can see index.html, test.html. So we've got two programs, and again, by a convention in STEMCstudio, the TypeScript file that runs when index.html is executed or called to display itself is the corresponding root with .ts on the end. So here you can see test.html and test.ts. Because I have two HTML files in my project, I get an extra menu option that allows me to pick which program I want to run. Okay, so let's just choose program menu. So I can run, for example, the actual main program. Oh, and there's not much going on in this program. I'll show you it in the other program. So not much to see there. Or I can run the tests. Okay. So we talked about multiple programs. One of them is like, maybe your test program. The other one is like your main program, how it calls tests. Now in turn, tests contains the complex spec. So complex.spec, you can see here, and it's imported with that name. Okay, or rather that is the name that is exported here from your file. Okay, so that is imported into the test.ts file. And if we do control find here, then you can see that we have this describe complex spec. So this structure in this file and the way that this is kind of like working is it's different from how you would do it in a desktop program. But the essential and the important thing is that the way that you write the specs is actually exactly the same as you would write it in a normal library. So you can basically use all of the power of the testing framework here to do very standard testing. Okay. All right, so we have in here in our complex spec, you can see that we have several functions, and these functions are provided by the testing library. The testing library is actually called Jasmine. It's been a popular testing library, testing framework for quite a long time. And it provides a number of functions. One is the describe function, which allows you to set up sort of contexts of this, this is the context in which I'm doing the sort of the test. And then there's a function called it, which is what's called an expectation. So, and these things can have names. And then when these things run, the describe and the it, you can see a particular function that we pass in is actually run. So how does that relate to the output? Well, over here, you can see the word constructor, and that corresponds to the constructor word text over here. And then you can see it should preserve the real argument, that corresponds to that. So if you're wondering where the complex kind of comes from, excuse me, some of you may have seen that that was actually here. So you can actually have multiple specs here for different things in this file too. Okay, let's go back to our specs. And as I said before, the structure of these tests is as follows. There's a kind of a setup phase where you set up the test. Then there is a kind of moment where you execute the test with that, and then there is the assertion. Now, because this is STEMCstudio, it's possible because we have TypeScript, it's possible to use auto completion here, and you can see that there's a whole bunch of to be functions here that you can call. Expect this to be greater than, or to be less than, or expect it to be something or other, whatever, right? So pretty powerful in terms of the basic options that they give you. And you can usually end up writing your own functions if you need to augment these. Okay, so just in case you want to see the documentation for that, obviously there's kind of like inline document, but the formal documentation can be found by going to the project settings, looking for Jasmine, go over to this link over here, and then that'll take you into some really great documentation that is provided by the Jasmine code. Okay, So let's close that, come back to here. And now that we've done this, let's actually see how we add automated testing to an existing program that actually doesn't have it, because most projects that you start won't have the automated testing framework in. So here is the current geometric number, the state of play for our geometric algebra course, where we don't have any testing yet. And just in case you're wondering, like, why am I not doing test-driven development here? The reason is because I wanted to keep the focus on the math and implementing the math, and also let the geometric class, excuse me, stabilize, so that I wouldn't be kind of like continually thrashing around, changing tests, changing the code and that kind of thing. So we've got to a point right now where things are kind of quite stable, but there's much more to be, no, I wouldn't say much more to be added, but there's quite a bit that we will add. And we also want to really make sure that this geometric number is really bulletproof, because we're going to base future projects off it. Okay, so how do we write a test for this class, which is called geometric? Okay, well, the first thing is we have to bring in those other test files, right? We have to bring in a test.html file. We have to bring in the corresponding test.ts file and any other files that kind of are needed. And this could be quite a chore if you had to do it by hand. And it also, wouldn't give you necessarily the most latest kind of way of doing it. So what I've done is I provided an option in the project menu. So you go up to the menu bar, click the project menu, and you can add a testing framework. In this case, it's Jasmine. So adding all of the files you need is as easy as just clicking on that. And as you can see, I get my HTML file. I actually also get a different documentation file. But we won't really kind of use that. But maybe, you might want to write some documentation that's specific to your tests. So here's your HTML file. Your HTML file is actually bringing it in its own style sheet, just in case you want to make it sort of pretty. And then here's the main test file that is called by the test.html. And then here is the sample test file. So let's run this thing. Let's run tests. I'm going to hide the documentation, not really interested in it. So you can see here, this spec function here is basically what I want to do for my testing. Now, actually, what I'm going to do is I'm going to depart from like renaming this. I think what I'll do is I'll add a file, because I think that illustrates kind of like just how to add it. So I'm going to create a file which is called e2ga.spec.ts, just by convention, right? Because I want to kind of keep it so that when you see the e2ga file, you want to use, you want to kind of like know that this is the testing file for it. I'm going to kind of copy this one just because that's kind of a good template for me. And finally, I need to bring my e2ga spec into my tests program. So let's just give this a slightly different name. So we're going to call this geometric spec. Okay, I just need to deconflict the name with the word spec that's already in our tests here. Okay, so let's go down here, and so you can see how this goes. I want to import something or other from the file, which is called ./e2ga.spec. And if I put my cursor over here, control spacebar, there's only one thing in there, so it comes in. And little formatting there, just format the document. So I want to now use this because it's just complaining that it's declared, but it's not read. So there may be multiple words specs, or yes, I thought there might be. Let's just go and find it. Actually, I could do find usages. That would be nice. So if I right click on that, find usages, and I go to test spec and or test.ts, there's the describe. So what I want to do here is to get my new geometric spec, describe geometric, And I want to bring in the geometric spec like that. So actually now we've got two tests running. We've got the original spec and the geometric. Okay, I just did that to illustrate. We're actually not going to use the test, so I'm going to delete that. I'm going to delete that one. That should have left me with a little error at the top. It did indeed. So let's delete that. And we should be good there. Go back to the files view in the Explorer, and we don't need this test.spec anymore. This was just a kind of a template. Okay, so I could have modified that. I just chose to add it. Okay, so let's now actually write a test that's going to test our E2GA class. And you have to sort of, when you create tests, you kind of like want to build on your tests, build the sophistication. So the first thing you really kind of like have to test is really the basic construction. You know, does constructing a geometric actually work? All right, so let's go to our spec, and we want to do something like this. We've got a geometric constructor, and then we can say something like when called, and you can have as many of these describes nested as you want, and what you can see, it's going to build a kind of, it's going to build a sentence here, right? And then when called, I want to do something like, I want to check each coefficient in time to make sure that it's preserved, right? So it should preserve the A coefficient. The A coefficient is the scalar coefficient. Don't worry about this if you haven't gone and done the geometric algebra course. It's just a property, a number of the geometric class. Now, of course, we're testing the geometric class, so we better bring in the geometric class. So let's import from, and the file we need to import from is ./e2ga. And if I hit Control Space Bar there's only one thing, which is geometric, so we can bring that in. And now what we want to do is we want to do the setup. So we want to create something, and then we want to do some testing. So the appropriate place here to create it would be inside the constructor describe context, right? And we say const g equals new geometric. And what we need to do now, I'll just hover over here, is we need to pass in a, x, y, b. So 0, 0, 0, 0. And I'm going to be a little bit picky here. I noticed that my documentation for my geometric is not saying anything about the b coefficient. Okay, so I've forgotten that. So let's just go to that. It's always nice to document, because then you can actually test according to your documentation. So param b is the coefficient corresponding to the E1 wedge E2 basis bivector. Okay, and then constructs the scalar vector. Well, so it constructs actually the multi-vector. And I think, you know, it's not important what the name is, obviously, but we're going to add plus b multiplied by E1 wedge E2. Okay. All right, let's just hover over that. Let's take a look. Constructs the multivector M, which is A plus X times E1 plus Y times E2 plus B times E1 wedge E2. And then you can see that we have the descriptions for each of the parameters. Okay, so far so good. And you can see that these parameters A, X, and Y and B are public properties. So we expect these things to reflect you know, the constructor call. Okay, so G is not used, and what we need to do is we need to say what's the expected what's the actual property that we're looking at, which is G dot A, and we want to say expect G dot A to be, okay, and clearly the thing it needs to be is 0, and you can see that the tests have gone green. Okay, if I'd have written 1, then that wasn't correct. You can see that you know, 0 is what's being passed in for A, and it should preserve the A coefficient. Okay, now this is a bit of a weak test because, what if my geometric was actually like hard coded to 0, right? I mean, if I did that, I would get a pass, but what if geometric was just hard coded to 0? And that's what I might do if I was doing test-driven development. I might just hard code everything to 0. Okay, but we want to be, a little bit more well-defined than that. So what I'm going to do here is I'm going to pass in a random number for A. So there's A is math.random. I want to pass that in to my geometric. And you can see how the test is failing now. The geometric constructor, when called, should preserve the A coefficient. So I know what test is failing. I go right to it. And of course, I'm looking for A in that position. Okay. And you could just kind of like keep on going on here. You can create an X, you can put the X in this slot, and then you can copy this it and just put it afterward and say it should preserve the X coefficient and so forth. Okay. Something else you could do here now, obviously if I put lots of these expectations, then, my testing could kind of like get a little out of hand, like a huge file. And, I could do something like this. I could say check g.x, expect g.x to be, and I'll just make it 0 right now too, to make sure it's testing. And you can see that it's good, but what if it had failed, right? G.x is actually 0, but I expected it to be 1. Okay, well now I get geometric constructor should, when called, should preserve the A coefficient. Well, clearly this documentation is wrong. It should say, should preserve the coefficients. And, I basically have to go into the code and figure out which one is wrong. So you can see there's an engineering trade-off here. How much time do you want to spend debugging when things go wrong versus, how much kind of like code you want to write in your tests here. Okay. And, I think that's kind of like a matter of taste. My general approach is I'm going to spend more time testing the complex functions than I am testing the simple functions, but I'm going to provide some basic coverage of the simple functions. Okay, I don't think there is much more to be said at this point, so I think we'll wrap up there. So we've looked at automated testing. It is possible in STEMCstudio. It is very valuable because the expectation is that you're going to write more things from scratch, and therefore you're going to have some complicated functionality that you want to make sure works. In another video, I'm going to show you how you could, for example, use this geometric class in another project in a kind of like a method of code sharing that we call references. If you want to sort of shortcut that and kind of like find out how references work today, any of the examples, some of the top examples will actually show you how to use a reference. But I'm going to show you how to do that. So what you can do is you could develop your geometric class here in its own project, and you could give it, a ton of testing. You could have your own visualizations, what we call sort of debug visualizations, which are things that you implement just yourself, just to visualize, is this thing kind of working? But then you could use just the geometric class by itself in another project, and you wouldn't be kind of like carrying all this extra baggage with you. So that's kind of nice. All right, I hope that was interesting. Testing it can seem a bit of a dull subject, and it seems like it's not really adding any value. But actually, if you take it as a challenge and you take pride in your software and your craft, then I think it makes a lot of sense to invest an appropriate amount of time in testing. And then, you can be confident that your software is going to work. Okay, until next time, I'm going to probably carry on with the geometric algebra series and finish that off. And I will be using this automated testing in a kind of a test-driven development way to complete some of the final functions. So if you want to see more of that, go over to the geometric algebra in STEMCstudio video series. Okay, thanks very much. Happy coding, and we'll see you next time. Goodbye.